Okay, so now we're going to graph. On this one, a couple things I want to take note on. On here, this blue graph here is actually just the basic sine curve. The blue graph is really, this blue graph is just y equals sine of x. So it has an amplitude of 1 and a period of 2. So our amplitude is equal to 1. Our period is equal to 2 pi. And so I just want to compare what a sine graph where we change the amplitude and the period looks like to the parent graph of y equals sine x. Few things that we want to look at. I like to look at what my a and my b are. So we're working with the graph y equals a sine b of x. So my a here is equal to -3. That means our amplitude, my graph is going to stretch up rather than going to 1, it's going to stretch up to 3 and stretch down to -3. Our amplitude is always going to be the absolute value, so my amplitude here is 3. This negative, though, we need to keep this negative in mind. What this negative means is that we're going to flip our graph. So we're going to flip our graph over the x-axis. And if you recall, when we did our graphing back before Christmas, if we had a negative on the outside of a function, that means we were going to reflect our y's, which really flipped our graph over the x-axis. So this graph is going to flip over our x-axis. So rather than going up first, we'll go down first. We also need to figure out our period. So here my b is equal to 2. My period is equal to 2 pi over b. So my period is really 2 pi over 2, or a period of pi. So it's going to take a length of pi for one cycle to occur. So my amplitude is 3, my period is pi. How I like to graph these is I like to mark out my period first. So it's going to take from 0 to pi for my one cycle to happen. So I go off and mark my period will end, or my curve will end at pi. Here's my halfway point, pi over 2. I'd like to look at halfway between that is pi over 4. And then I count over 1 pi over 4, 2 pi over 4. This is 3 pi over 4. I want to mark those points off. Now I have 5 points that I'm working with. And those are the 5 points that we talked about in the beginning about going around the circle. So we know the sine graph always starts at 0. So my sine graph is going to start here at 0. I'm going to go down first. My amplitude is -3, so I'm going to go down a quarter way around the circle. I'm going to go down to -3. I'm going to go back up to the middle at pi over 2. I'm going to go, my graph isn't quite big enough here, so I need to extend this to be 3. I'm going to come up to 3 and back down to the middle. So I've flipped my graph, I've stretched it vertically to an amplitude of 3, and I've shrunk the period now so that it happens, instead of going to 2 pi, the one cycle will happen a distance of pi. So what does my curve look like? I come down, back to the middle, back up, and back down. Always extend and add a little arrow. I'm kind of picky about that because our graph goes on forever, so you want to extend an arrow to show that the graph just doesn't end there at pi. And we want to have 2 cycles, so then I always like to go in the negative direction. So I'm going to come up here, back down to the middle, back down, and back to the center. And include an arrow. So like I said, the points that you want to use start at 0. Here we're going to go down first because it's a negative, back to the middle, up top, back to the middle. So 1, 2, 3, 4, 5 kind of critical points that we want to make sure that we know. Let's do the next one. Here we want to look at, now we're using a cosine graph. So I want to remember cosine usually starts at 1, but we've changed our amplitude. My amplitude now is 5/2, so I'm going to start at 2.5. So my amplitude is 5/2. My b value is equal to 3, so my period is going to be 2 pi over 3. Let me do it like this. It's really 2 pi over b, and we know that b is 3, so it's 2 pi over 3. So here I don't have the sine graph. If you notice, let me go back here for a minute. If you notice on this one, look at the difference. If I look at my sine graph here, this is 1 cycle to 2 pi, just the basic parent graph. I've now shrunk that and flipped it. You can see that I've now shrunk it to pi and I flipped it. I meant to say that before. So now we're back here. I'm not going to compare it to, now I just want to graph it. And I don't have the parent graph on here. So I want to come up with my period. So what I do is I mark off 4 sections and I put out my period there. 2 pi over 3. So I know my 1 cycle is going to end there. So my critical points are going to happen here at 0, the first section, the second, the third. So I have my 5 points here. So 2 pi over 3 is where I'm going to end. I always like to find half that distance then. Let's find the middle of it. So if I take 2 pi over 3, multiply it 1/2, that'll give me that half distance, so 2 pi over 6, which is pi over 3. Then I want to find half the distance between 0 and pi over 3, so I'm going to take pi over 3, and I'm going to multiply it times 1/2. That gives me pi over 6. So this distance is pi over 6. Once I have those distances, then I count over. So to find my next marking, that third one over, I think pi over 6, 1 pi over 6, 2 pi over 6, 3 pi over 6 is going to be the next one, but 3 pi over 6 simplifies down to pi over 2. So this is going to be pi over 2. I'm going to have to do 2 cycles, so I'll go in the negative on the other side. My amplitude is 5/2, so that's going to be 2.5. This is a cosine curve, so I don't start at 0. Normally I start at 1, but I'm stretching that vertically, so I'm going to start at 2.5. I go back down to the middle, go down to 2.5, up to the middle, and then up to 2.5. And so this is my cosine curve. Like I said, kind of show that this curve goes on. Add an arrow there. I'll be kind of picky about that. And then we can go on the other side. I'm going to go start at 2.5, go down to the middle, down to 2.5, up to the middle, up to 2.5. That's a bad curve. Let me do that again. And there's 2 periods of my cosine graph. One more to do. Here's the last one. Now we're back to a sine graph. So we're going to graph this. This is y equals 3/2 sine of pi over 2 times x. My a here is 3/2. My b is equal to pi over 2. So my period is going to be 2 pi over b, which is 2 pi over pi over 2. So we don't want to leave it in this complex fraction. Really, this is saying divide it by, so I can say 2 pi times 2 over pi, right? Because I can say that's just really a division problem. My pi's cancel, and I end up with a period of 4. So I'm going to go over 4 spots on my graph. 1, 2, 3, 4, and that's the end of my period. That'll be where one cycle ends. Half of that is 2, half of that is 1. So that's what I'm going to look like. This is a sine graph. My sine graph starts at 0. I have an amplitude of 3/2 or 1.5, so my peaks, my maximum and min will be at 1.5. So I start at the middle, up high, back to the middle, down low, back to the middle. I can extend this in the negative direction. So here's my 1 cycle. And then I can show 2 cycles by going here to 1.5. So I start at the middle, down low, back to the middle, up high, back to the middle. And you'll start getting used to that pattern, remembering that cosine doesn't start at 0 and sine does start at 0. The next example is going to look at a graph and writing the equation based on the graph.